Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
For part A, let's go ahead and balance the equation. Unbalanced, we're given H3MO3 aqueous, where M is an unknown metal. We don't know its identity. H3MO4 aqueous and Mn2 plus, and we're told that this occurs in acidic solution. Break this apart into two half reactions, H3MO3 to H3MO4. M is balanced on each side. Oxygen is not balanced, so H2O on the left-hand side. That gives me 5 hydrogens on the left, 3 hydrogens on the right, so 2H plus on the right. Let's balance the charge by 2 electrons on the right. Second half reaction, MnO4 minus to Mn2 plus. Manganese is balanced on each side. Balance the oxygen by adding 4H2O. Balance hydrogen by adding 8H plus. And let's balance the charge by adding 5 electrons on the left-hand side. Now we need to multiply to cancel out the electrons, times 5 and times 2. Multiply the first half reaction by 5. Multiply the second half reaction by 2. Cancel out the electrons. Hydrogens will simplify. H2O will simplify. And I am left with our balanced equation, 5H3MO3, 2MnO4 minus, 6H plus, to 5H3MO4, 2Mn2 plus, and 3H2O. For part B, how many moles of oxide were formed and how many moles of the semi-metal were in the original 0.2 gram sample. So let's find the, first of all, the mole of MnO4 minus from the information given. We have 10.7 milliliters, or 0.0107 liters of MnO4 minus times its molarity, which is 0.1 moles of MnO4 minus per liter of MnO4 minus, and this would yield 0.00107 moles of MnO4 minus. Now we can calculate the moles of the oxide, starting from 0.00107 moles of MnO4 minus times 2 moles of MnO4 minus to 5 moles of H3MO3, and then the oxide, 2 moles of H3MO3 to 1 mole of M2O3. So therefore we have 1.33 times 10 to the negative 3 moles of the oxide M2O3. and then how many moles of the semimetal? Starting from 1.33 times 10 to the negative 3 moles of the oxide, 1 mole of the M2O3 has 2 moles of M, and this would be equal to 2.67 times 10 to the negative 3 moles of the semimetal M. And lastly, for part C, what is the identity of the metal M? So the atomic mass of M, we're told that we have a 0.2 grams of the metal and 2.67 times 10 to the negative 3 moles, and this will yield 74.9 grams per mole, which corresponds to the element arsenic.